We are in Chapter 1, Functions, Graphs, and Limits. The material presented in sections 1 through 4 of Chapter 1 is considered to be material already mastered. This document provides a brief outline of the key concepts in sections 1.1 through 1.4. If you're having difficulties with this material presented in these sections, I encourage you to sign up for the free marks and the ASAC Tutoring Center at Mount San Antonio College and go over additional examples in the textbook. So the first section that we have is section 1.1, which deals with functions. A function is a rule that assigns to each object in a set A exactly one object in set B. Set A is called the domain of the function, and B is called the range of the function. And there's an example there that has the domain mapping to something in the range. And if you notice, each element in the domain maps to exactly one element in the range. The domain of a function depends on what function it is that we are dealing with. A polynomial function has a domain of all real numbers. Another way to write this would be from negative infinity to positive infinity. And then another way to write this is with our special R, which symbolizes all real numbers. A rational function would be a function of the form where you have a numerator and you have a denominator. So I'm going to go ahead and call that n of x for numerator and d of x for denominator. And this is going to be, our function would have a domain of all real numbers, except where the denominator would be equal to 0. And we have different ways to write our answers that are going to be discussed more in detail below. And then we also have an even root function. And so this is where you would have a root of something, and we're going to go ahead and say where this would be some kind of expression in here, and this would be an nth root, but this n here would be even. And for an nth root, this would be only where our function is going to be greater than or equal to 0. And then note if it is an odd function, so we'll say a little note here. If we have an odd root function, this is going to have a domain, has domain of all real numbers. So we have a couple different ways to express our answers correctly. And so they are going to require us to use different ideas that we've talked about in previous courses. So if you guys remember from graphing a inequality, you would either have an open or a closed dot. And that closed interval, we're going to be using brackets. And for an open interval, or like that open circle, we are going to have parentheses. And so below, you'll notice that we have some examples, definitely stuff we need to know. And we're going to have both interval notation and set builder notation. And so if those A and B have open circles above them, we'll be using parentheses. And if they were to have closed circles, and this is back from an algebra class or even pre-algebra, you would have brackets. And if you notice the set builder notation, you have a brace, and then you have a straight up and down line, and this stands for such that. So this is going to be x such that x is between A and B. You'll notice the same thing down below, except for instead of less than and greater than, you're going to have less than or equal to and greater than or equal to. And the other two cases are right below, depending on if you have one that's included and one that's not included on those endpoints. The example on the next page says find the domain of each function. Write the domain in interval notation or in set builder notation. I'm going to go ahead and write them both ways so that way we get some practice. So the first one that we have, this is a polynomial, and a polynomial has a domain from negative infinity to positive infinity, and you can use that r that we discussed earlier. Part B, this is a rational function, and so if you remember with a rational function, that's going to be our denominator is not allowed to equal 0. So I'm going to take our denominator and say this cannot equal 0. So going ahead and solving this, we say that 3 cannot equal 2x, or that x cannot equal 3 divided by 2. So this way of writing our answer like this is not calculus material. So we want to be able to write this in either interval notation, which is then go from negative infinity to 3 over 2, which has a parenthesis since it's not equal to or not included. And then we're going to say union 3 over 2, comma, infinity. Or we can write it in set builder notation, which again starts with that brace. We write x such that x does not equal 3 over 2. So make sure you're familiar with both of these notations. For part C, we have an even root. This has no little value on the outside, which means that we're actually dealing with a square root, which is even. And for a square root or an even root, we have to take our function, which is inside that radical sign, and we can say that it's going to be greater than or equal to 0. Going ahead and solving this, adding 3x on both sides, and then dividing by 3. I'm going to rewrite this in my x values first. It makes it a little bit easier for me to read the inequality and rewrite it in either interval notation or set builder notation. So it says that x is less than or equal to 1/3. And so you can write this in interval notation. So less, that means it goes all the way through to negative infinity up to 1/3. 1/3's included, so we're going to go ahead and put a bracket. Or we can have our set builder notation, which we put a brace, x such that x is less than or equal to 1/3. The next example we have says if f of x equals 3x squared minus 5x plus 1, find the following. So the first one that we have is going to be f of 4, and f of 4 is found by substituting in 4 every time you see an x. And so we're going to go ahead and substitute that in. If you work this out and simplify this, you're going to get a value of 29. The next value that we have is -2. Just like it was with 4, we're going to go ahead and substitute this in every single time that we see an x. So we have 3. Make sure you put the -2 in parentheses squared, minus 5 times -2 plus 1. And then simplifying this, remember that squaring a negative actually makes it positive. So this is going to be 3 times 4. And then we have a negative and a negative, so plus 10 plus 1. And this simplifies out to being 23. Part C, this time we don't actually have a number, but we have a letter or a variable in here. And so to find f of a, we're just going to substitute in a every time we see an x. So we're going to have 3a squared minus 5a plus 1. And if you notice, you're unable to simplify this at all, and this would be your final answer. The next example that we have says c of x equals 2x minus 5. Find c of x plus h. So this time, instead of substituting in 4 or -2, we're going to substitute in x plus h in every single time that we see an x. So c of x plus h is going to equal 2. And now instead of writing x, we're going to substitute this in for it. So we're going to have x plus h minus 5. You can leave this as it is, or you can actually distribute the 2 if you would like. Those are equivalent answers. You can't simplify anymore, so both of those would be correct. The next definition that we have is a piecewise function. This has multiple functions, and each of these functions applies only to a certain interval of the main function's domain. So an example of that's right below. and h of x equals, and it says 6x minus 1, and this is only if x is smaller than 0, so less than 0, and then 7x plus 3 if x is greater than or equal to 0. So for the first one, it's asking for h of negative 1, and so since it's less than 1, the value that we're going to be substituting negative 1 into is going to be the 6x minus 1. So I'm going to go ahead and substitute in negative 1. And when we work this out, we get negative 7. For the second one, we have h of 0. And 0 this time is actually going to be using that second expression that we have. So 7x plus 3. So we're using the second part of this. So we're going to have 7 times 0 plus 3, which works out to being just 3. The next set of definitions we have deals with our business part of this class. So we have a demand function, which we call d of x. For a commodity is the price P, which is equal to d of x, that must be charged for each unit of a commodity if x units are to be sold or demanded. And then we have a supply function, s of x, for a commodity is the unit price, P equals S of X, at which producers are willing to supply X units to the market. So definitely words that we need to know. Along with revenue, R of X, this is obtained from selling X units of the commodity, is given by the product. It's the number of items sold times the price per item, or x times p of x, and that's going to be our revenue. And then we have a cost function. C of x is the cost of producing x units of the commodity. We have a profit function. P of x is the profit obtained from selling x units of the commodity and is given by the difference in our profit's going to be revenue minus cost. And so there's a few different ways to write it there. I also want you to realize that capital P is what the book is using for profit, and lowercase p is representing a price. Then we have average, cost, revenue, and profit, and these are all the same. I want you guys to realize these are also called unit cost, unit revenue, and unit profit. And so in order to do this, you're going to take your cost function and divide by x. The way our book writes it is A of C for average cost, A of R for average revenue, and AP for average profits. The next thing that we have on here is going to be our demand and our supply graph. And if you notice on here, we have a point of equilibrium. And our point of equilibrium is going to be where your supply is equal to your demand. It requires us to find a point of intersection. The composition of a function is where we're given function f of u and g of x. The composition is going to be f of g of x, or the other way to write is with this open circle. So f of g of x is the function of x formed by substituting u equals g of x for u in the formula f of u. So the next example that we have says Arthur, the manager of a furniture factory, finds that the cost of producing Q bookcases during the morning production run is equal to C of Q equals Q squared plus Q plus $500. On a typical workday, Q of T is equal to 25 T bookcases are produced. During the first T hours of production ran from 0 to 5 hours. Part A says express the production cost C in terms of T. So we want our production cost C, but this time in terms of T. If you look at your cost function up above, it's in terms of Q. So we also know that Q of T is equal to 25 T. So we're going to make a composition function here. We're actually going to have C of Q of T. And we're going to substitute this into our cost, which was 25T, just like we did previously. And so we're going to have 25T squared plus 25T plus 500. And this would be in dollars. You can simplify this. Make sure that when you square 25 and t, you're squaring both of those. And so 25 squared is 625. T squared plus 25t plus 500. Part B says how much will have been spent on production by the end of the third hour. What is the average cost of production during the first 3 hours? So there's two questions here. The first one wants us to know what is going to be the cost after hour 3. And notice that this is a time. So we're going to be substituting into our equation up above that I just boxed. And so we're going to have 625 times 3 squared plus 25 times 3 plus 500. And working this out, we get $606,200. Our average cost at 3 hours is going to be our cost at 3 divided by 3. So we have $6,200 dividing by 3. So our average cost is about, around 2 decimal places since we are dealing with money. 0.67, so $2,066.67 per hour. Part C says Arthur's budget allows no more than $11,000 for production during the morning production run. When will this limit be reached? So we're going to take our $11,000. This is our cost that we have. And wants to know when will this be reached. So wants us to know a time. So I'm going to go ahead and use our cost, but in terms of t. So we have 625 t squared plus 25t plus 500. And so solving this is a quadratic, and I'm going to need to move my 11,000 over to one side. So I'm going to subtract 11,000, so I have that equal to 625t squared plus 25t minus 10,500. We have 0 equals, we're able to divide everything through by 25. So doing that, I get 25t squared plus t minus 420. And so from here, x is equal to, and this is not going to be able to factor nicely. So what we're going to use is our quadratic formula, which is going to be -1 plus or minus the square root of, we're going to have 1 squared minus 4 times a times c. And then we divide this all through by 2 times a. And substituting all this in on your calculator and simplifying it, I'm going to go ahead and round just 2 decimal places. So it's going to be about 4.08 hours. The next example says if f of x equals 3x squared minus x and g of x equals x minus 1, find f of g of x. So I'm going to go ahead and put an f, and you always start on the inside with composition functions and work your way out. So putting the minus x minus 1 into my function of f. So looking at my function f up above, I'm going to have 3x minus 1 squared minus, and then x minus 1. So from here, we're going to go ahead and simplify this. You should always simplify. So we have x minus 1 squared is going to be x squared minus 2x plus 1. We have minus x plus 1. And then we end up with 3x squared minus 6x plus 3 minus x plus 1. And then from here, simplifying this to combine my like terms, we're going to have 3x squared. We do have a negative 6x and a negative x, so minus 7x. And then we have a positive 1 and a positive 3, so plus 4. The next example right below this is actually working backwards, and this is very useful for the upcoming chapters that we have. So this one says, if f of x equals 5 over x minus 2 plus 4 times x minus 2, find the function g of x and h of x if f of x is equal to g of h of x. So if you look at this problem that they gave us, there is an x minus 2, and I see that down here in the denominator, and I also see this in here, the parentheses. So that's my inside function. So I'm going to go ahead and say that's what h of x is my inside function. And I replaced the x that was there for my outside function, which is going to be g of x. And g of x is going to be 5 over x plus 4 times, and instead of x minus 2, we just write an x. And now see if you can rewrite this function f of x if you were given h of x and g of x, just to double check to see if you got that correct. The next section that we have is the graph of the function. Any point P in the plane can be associated with a unique ordered pair of numbers x, comma, y. The first one that we have here, this first picture that we have, is a rectangular coordinate system that we deal with. You'll notice we have an x-axis, we have a y-axis, we have an origin, and then we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Normally we are dealing with business types of problems. We're going to be dealing with everything in quadrant 1 because a lot of times our x-axis is going to be time, and time is never negative. However, there are some situations where maybe we are going to be dealing with negative time, or maybe we're not dealing with time, we're dealing with production cost or something like that, and negative does represent a loss. So this is the different quadrants that we have. The next to that is an example that says plot the following ordered pairs on the xy plane and state which quadrant the point lies in. So the first value that we have is a, which is 0, 4. That's not in any quadrant, that's actually just on the y-axis. Then we have b, which is at -3, 0, which is not in a quadrant, it's on the x-axis this time. Then we have c, which is going to be 2, 3. This one is in quadrant 1. Then we have d, which is going to be -4, -1. We have e, and d is in quadrant 3. E, which is -1 and +4. And e is in quadrant 2. Down below, we have the distance formula. The distance between 2 points, x1, y1, and x2, y2 is given by, it's the square root of subtracting those x values and squaring them, and then adding the difference of the y's squared. The example below says find the distance between the points -2 and -5. So I'm going to go ahead and call this x1, y1. The second one, x2, y2. And in order to find my distance, I'm going to go ahead and write a giant square root. I'm going to do x2, which is 1, minus x1, which is -2, squared, plus the difference between the y's, which is going to be -3 minus -5, squared. And then simplifying this, I'm going to have 1 minus -2, which is just going to become 3, squared, plus -3 plus 5 is going to become 2, squared. Simplifying this, we get 9 plus 4 and the square root of 13. Go ahead and leave my answer like this. If it did ever tell you to round and approximate this to a certain amount of decimal places, then you can definitely plug that in on your calculator. The next example, we're going to go ahead and circle, and this is one that we will work on together in class. The one right below it says find the points of intersection. if there are any, if you are given the curves, and then it also tells us to sketch these. So the first one that we have is going to be y equals x squared minus x, and the second one is going to be y equals x minus 1. So I'm just going to say, where do these two values of y equal each other? And that would be when we have x squared minus x is equal to x minus 1. And then to solve this, since we do have a quadratic, we're going to go ahead and move everything to one side. So I'm going to subtract x, and I'm going to add 1. And then from here, we're going to go ahead and factor. This actually factors really nicely. And so we're going to have x minus 1 and x minus 1. That means that this is the same thing as x minus 1 squared equals 0. Solving this, we're going to square root both sides. Put a plus or minus, but that's still just going to be 0. Add 1. We get a value of 1. It does say to find the point of intersection. So in order to find that point of intersection, I'm going to pick one of these equations to substitute back in. I'm going to go ahead and use this second formula just because that equation looks a little bit nicer. So it's y equals x minus 1, or y equals 1 minus 1, which is going to be 0. So my ordered pair is going to be 1, 0. It does also tell to sketch the graph, and I'm going to leave that to you guys. One's a parabola, one's a straight linear line. So I'll let you guys look at that on your own. The next definition that we have is the vertical line test. This is a curve as a function if and only if no vertical line intersects the curve at more than once. This is defining if something's a function. And then we have an x and y intercepts, and this is where our graph is going to cross either the x or the y axes. And so in order to find our x-intercepts, we're going to set y equal to 0 and solve for x. And then we're going to set this as an ordered pair. This is going to be x, 0, since our y was a 0 value. For the y-intercept, we're going to set x equal to 0, and we're going to solve for y. And so our ordered pair is going to be 0, y. So the next example right below that says find the intercepts. And whenever it says intercepts, that means both the x and the y-intercepts of the graph for each function. And so we're going to go ahead and take our function here. And to find our x-intercepts, we're going to set y equal to 0. And so we have 0 equals negative x squared plus x plus 2. I'm going to go ahead and multiply everything through by a negative. It makes it easier for me to factor. So I have x squared minus x minus 2 equals 0. Factoring this, we get x minus 2 and x plus 1 equals 0. Solving both of these, you have x minus 2 equals 0, or x is equal to 2, and x is equal to negative 1. Again, we need to write these as ordered pairs. So we have 2, 0. And we have negative 1, 0. Not writing them as an ordered pair is technically incorrect because this is a two-dimensional, not a one-dimensional answer. So the next thing we have is a y-intercept. To find your y-intercept, you're going to set x equal to 0. And we have y is equal to negative 0 squared plus 0 plus 2. And this simplifies to just y equals 2. So our ordered pair is going to be 0, 2. The next example is h of x equals x times the square root of x squared minus 1. In order to find our x-intercepts, we're going to go ahead and set y equal to 0. So we have 0 equals x times the square root of x squared minus 1. Separating this, we're going to have x is equal to 0, and the square root of x squared minus 1 is equal to 0. Squaring both sides, you get x squared minus 1 equals 0. Adding 1 on both sides, you get x squared equals 1. Square rooting both sides and putting a plus or minus means that we're going to arrive at x equals plus or minus 1. Writing this correctly as ordered pairs, we're going to have 0, 0 for our y, we have 1, 0, and negative 1, 0. So these 3 points would be our x-intercepts. To find our y-intercept, we're going to set x equal to 0. Setting x equal to 0, we're going to have y equals 0 times the square root of 0 squared minus 1, which works out to be 0. So we get an answer of 0, 0 for our y-intercept, which we saw previously. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. The domain of a quadratic function, since this is a polynomial, is going to be all real numbers. Another thing that we've already seen, but we should probably have written down, is our quadratic formula. And the quadratic formula is going to be x is equal to, and it's negative b plus or minus the square root of b squared minus 4 times a times c. This is all over 2 times a. And this allows us to solve a quadratic function that we would have when we cannot factor it. A quadratic function in standard form is of the form f of x equals ax squared plus bx plus c. And these create parabolas, and a parabola is a shape of a graph that's going to be U-shaped. And the sign of the leading coefficient a determines if the parabola is going to open up or open down. So it's going to open up if a is positive, and it's going to open down if a is negative. And you can see that in the picture right below. And from this, you'll notice that if it's opening upward, this point down here is going to be a minimum. And if it's opening downwards, the point up here is going to be a maximum value. And this point is called a vertex on both of these pictures here, this minimum and maximum, depending on if the parabola is opening upwards or opening downwards. So the vertex of a parabola is also called a turning point of a parabola, is the lowest point minimum on a parabola that opens upwards and the highest point a maximum on the parabola that opens downwards. To find the vertex of our quadratic function ax squared plus bx plus c, we're going to find the x value, and our x value that we need to know is negative b all over 2a. And then to find the y value, we're going to substitute that numerical value that we get back into our function. The next example says, suppose that when the price of a certain commodity in p dollars per unit, then x hundred units will be purchased by consumers, where p is equal to negative 0.05x plus 38. The cost of producing x hundred units is c of x equals 0.02x squared plus 3x plus $574.77. Part A says to express the profit p of x obtained from the sale of x hundred units as a function of x. So our profit p of x is going to be equal to our revenue minus cost. We don't have a revenue function in here, but we do have price times the quantity sold, so p times x, minus our cost, c of x. So price that we have is going to be negative 0.05x plus 38 times x minus our cost function, which is given to us, which is going to be 0.02x squared plus 3x plus 574.77. You can distribute your x value and then combine your like terms, and we're going to arrive at our profit function would be equal to negative 0.07x squared plus 35x minus 574.77. Part B says find the average profit, or AP, when the price is $37 per unit. And so if we remember, the average profit of x is equal to the profit of x units divided by x units. And we don't know how many units we have sold, but we do know that the price is $37. So we know that lowercase p is equal to 37. And so from this, we know that P, the price, is equal to negative 0.05x plus 38. So I'm going to go ahead and substitute in 37 for our price. Going ahead and solving this, subtracting 38, you get negative 1 equals negative 0.05x. Dividing by the negative 0.05, we get x is equal to 20. And so this would be our units, so we can go ahead and find the average profit of 20 units, which is going to be the profit for 20 units divided by 20 units. And figuring out the profit of 20 units and dividing by 20, we arrive at $4.86. This is going to be per month. Part C says, use the profit curve found in Part A to determine the level of production X that results in a maximum profit. What unit price corresponds to the maximum profit? So we need to figure out the maximum profit and the unit price that corresponds with it. So since we do have a parabola for this up above in Part A, we are able to figure that out by using our vertex formula, which is negative b divided by 2a. And so we're going to have negative 35 divided by 2 times a, which is negative 0.07. And again, look at your formula from Part A, and you'll see those values in there. Dividing this out, we're at 250, and that's going to be 100 units. Another way you can write this is the 250 and 100 has 2 zeros, so just adding that in. So we can say 25,000 units. And then it also asks for what unit price corresponds to the maximum profit. So that unit price of 250, 100 units, plugging that in, we get a value of $25.50. The next example, we're going to go ahead and circle and work on that one together in class. Then we get into section 1.3, which is on lines and linear functions. A linear function is a function whose graph is a straight line. We have different types of slope. We have positive slope, we have negative slope, we have zero slope, and then the last one that we have is undefined. And those pictures of all 4 of those kinds of slopes that we have are on the next page. And so you'll see positive slope is rising as you read the graph from left to right. Negative slope is falling from left to right. And zero slope is horizontal and flat. And then our undefined slope is a vertical line. So we get zero slope whenever you guys have a fraction that's going to be of the form 0 over some kind of number. And then undefined slope is going to be where you have a number over 0. To get these values, we're going to use the slope formula down below. Slope of a line that passes through the 2 points, x1, y1, and x2, y2 is given by m equals y2 minus y1 over x2 minus x1. Another way to think of slope is rise over run, change in y over change in x, or again, m, which is a variable that we use to represent slope. The next example says find the slope of the line passing through the points. And so we have 2 points here. I'm going to go ahead and label this x1, y1, and x2, y2. So finding our slope, I'm going to do y2 minus y1, and then x2 minus x1. And then going ahead and simplifying the numerator, we get negative 7 over 3. It's typical to leave our slope as an improper fraction, and this doesn't reduce, so negative 7/3. The next one we have says find the slope of the line passing through the points. And again, we have x1 and y1, and x2 and y2. So going ahead and doing the same exact formula, we have y2 minus y1 over x2 minus x1. So we have 13 minus 6, which is 7, over negative 20 plus 3 is 17, and that's going to be negative. I'll put the negative up on the top. Again, this does not simplify or reduce, so we would leave it like this. A method used to graph linear equations uses properties of the line. We will find the slope and the y-intercept of the graph and arrive at the slope-intercept form, which is y equals mx plus b. So the next example that we have says to rewrite the equation in slope-intercept form, state the slope, the y-intercept, and then graph. So in order to get this in slope-intercept form, we need to isolate y. So I'm going to solve for y, subtracting 3x on both sides. We have 2y equals negative 3x plus 4. Dividing everything through by 2, we get y equals negative 3 over 2x plus 2. And this is our equation in slope-intercept form. So the next thing it says is, what is the slope? I'm going to go ahead and use m for slope, and that's going to be negative 3 over 2. Our b value is 2. This is a y-intercept, so this is going to be your x is 0, your y is 2. So this is our y-intercept, and here is our slope. So from here I'm going to go ahead and put the y-intercept on my graph, which is at 0 for x and 2 for y. To find the next point, we're going to go ahead and use our slope, and we're going to go down 3 from this point and right 2. To find the next one, we're going to go down 3 again and right 2. Likewise, we can go up 3 and left 2 from the original point. Once you have that drawn in with those points, you can draw a straight line. Try to do the best that you can. The next examples are special situations that we come to see quite often. The first one says graph y equals negative 2, and the second one says graph x equals 3. So a couple things to notice that these are very simplified equations. So for the first one, since we don't have a coordinate plane, I'm going to go ahead and draw 3 lines each way. And so y is equal to negative 2 right here. And y is equal to negative 2 also at all these other points. So this is actually going to make a horizontal line that we would have. Likewise, for the next one, I'm going to go ahead and do the same thing and draw my coordinate plane, go 3 each way. And so x is equal to 3 right here. It's also equal to 3 right above and above. So this is going to be a vertical line. This would be an example of when our slope is undefined. In the example previously, the horizontal line is where our slope is defined as 0. From the slope equation below, if we have 2 points, x1, y1, and x, comma, y, we can derive the point slope equation that we have. And so the point slope form of an equation of a line, so we have slope m and it passes through the point x1, y1, and we have y minus y1 equals m times x minus x1. So the next example says find the slope-intercept form of the line with the given information. So we have our x1 and our y1. So we're going to do y, stays a variable, minus y1, which is negative 4, equals slope, which is negative 2/3, times x minus x1, which is 6. Simplifying and cleaning this up a little bit, we have y plus 4 equals negative 2/3 times x minus 6. And from here, this wants this in slope intercept form, which is going to be y equals mx plus b. So from here, I'm going to go ahead and distribute through my negative 2/3. So I have y plus 4 equals negative 2/3 x minus, and then multiplying negative 2/3 times 6, negative 6, we get positive 4. And then subtracting 4 on both sides, we get y equals negative 2/3 x. The next one we have is passing through points 0, 1, and negative 3, 0. So I'm going to go ahead and label this x1, y1, and x2, y2. And in order to do this problem, we first need to find our slope. So our slope is going to be y2 minus y1 over x2 minus x1, which simplifies to negative 1 over negative 3, or positive 1/3. Now you can use either point you want. So you can either use 0, 1, or negative 3, 0. They are going to simplify to being the same answer. I'm going to go ahead and use that first point. So I'm going to have y minus y1 equals m, which we just found was 1/3, times x minus x1. So we get y minus 1 equals 1/3 x, which simplifies to y equals 1/3 x plus 1. The example right below this, we're going to go ahead and circle, and we'll work with that one together in class. The next part that we have says there's an interesting connection between the slope of lines and if they're parallel and if they're perpendicular. Perpendicular means that they're going to meet, those lines will intersect at a right angle or a 90-degree angle. So parallel lines actually have the same steepness, so they have the same slope. So the slope of line 1 is going to be equal to the slope of line 2. And then perpendicular, you can see by looking at them that they're not the same, and actually one's positive and one's negative, and the slope of one is going to be equal to the reciprocal with the opposite sign of the other slope. The example below this says find the slope of a line parallel and perpendicular to the given line. So the equation that we have is written in slope-intercept form. So we have y equals negative 10 over 3x minus 5. So the slope is going to be negative 10 over 3. And so the slope of a parallel line would also be negative 10 over 3. And then the slope of a perpendicular line is going to be opposite reciprocal. And a reciprocal means you're going to flip the top and the bottom, or think of it as 1 over that value and cause it to flip. And so we're going to have 3 over 10, and the sign is going to be the opposite also. So this is going to be positive 3/10, and this is our perpendicular slope. I'm going to go ahead and circle part B, and we will look at that one together in class.